Welcome, hello, wherever you are. This is our first NEP Protocol Community Working Group meeting, which is very exciting. My name is Ori Applebaum, and I'm a technical program manager from Pagoda, and very excited to kick off this group and discuss a protocol proposal today. So just to go over the agenda, first, we will give a quick update on the NEP process and working groups, which may be a familiar concept to some of you. Some of you might be learning about it, which is great. Next, we will do some brief introductions as we have a few panelists joining us today. And then we will get into the main discussion, efficient signature verification host functions, NEP 364. And then we will open it up to Q&A. And if at any times you have questions, feel free to drop them in the Q&A button on the screen, and we'll try to answer them, as we go, or we'll save time for the end. So just to give a little bit background on the NEP process and the working groups. So Pagoda currently owns a lot of the software development for the entire NEAR ecosystem, and we recognize that in order to make meaningful progress and make decisions in a more decentralized way, we need to make it easier for the community to get involved. So the first step is that we've introduced a more formalized NEP process, NEAR enhancement proposal, earlier to help provide a mechanism for anyone to submit proposals, provide rationale, and build consensus. And so we've been getting NEP submissions, and we wanted to figure out a way, how do we move them forward, review them, make decisions, and determine the next steps so that they're not just sitting in an idle state indefinitely. And so that's exactly where the working groups come in. So the working group is really a way to operationalize the review of those NEPs. And Pagoda, in the short term, has selected a few leading subject matter experts to help bootstrap the first three working groups. So contract standards, protocol, and wallet standards. And we've already had the first contract standards meeting a couple of weeks ago, and now we're continuing with the protocol working group. And putting these groups into practice really will be a gradual approach and require flexibility as we work with the community to figure out what works and what doesn't. But in the long term, we really want to introduce more groups to handle various ecosystem needs and empower the community to run them. And speaking of iteration, that's why we're here today, is to actually kick off the protocol group and continue to bootstrap this process. So before we get into the content, just wanted to cover the roles that are involved in this process. So there are four key ones: author, which is the person who writes the proposal and presents it to the working group; moderator, the person who facilitates the process and helps validate that the proposal meets the guidelines and progresses forward; reviewer, subject matter expert, the person who assesses the technical viability, feasibility; and then approver, the working group member who help make the final decision. And so this may sound confusing if you're not familiar with the process. So here is a diagram to kind of illustrate it. So basically, there are three stages: draft, review, and voting, and two outcomes: approved and rejected. And all the roles that I just mentioned help move an NEP through this process towards the outcome. And so today we're here to do this part of the process, which is moving an NEP that has been in the review stage and making a decision on it. So let's go ahead and actually get to introductions. So I would like to hand it off to our first working group member to introduce themselves. Bowen, please take it away.
Hey everyone, I'm Bowen from Pagoda, head of protocol at Pagoda. I mostly lead work on research and development of the protocol. And yeah, very excited to be here.
I guess I'm next. Hi everyone, Marcelo, good to see you again in this working group. I'm working with Aurora, leading the protocol team. Yeah.
And hi, I'm Marcin. I'm also from Pagoda. I'm one of the developers for the protocol.
Great, thank you all. All right, next we're going to introduce the moderators. So Max.
Hey everyone, I'm Max. So also from Pagoda, but I'm not an approver. I just here to make sure we follow the process and answer the questions and facilitate. Yeah.
Hey everybody, I'm Vlad. I'm helping Ori with the moderating this work groups, and I'm also part of the working group for contract standards. So you can see me more often than other people on this call, but I'm happy to help to move things forward. And
Awesome.
Ori.
Yeah, so I guess I'll reintroduce myself. Hi, I'm Ori. And yeah, I just wanted to add that I'm playing a moderator role in this process. And so, yeah, really just trying to help iterate on these working groups. So please reach out, if you have any questions. And yeah, now I'd like to turn it over to the NEP author that we have here today. So Blas, hello.
Hello, guys. Nice to meet you all. Thanks for inviting me. I work at Composable Finance, and what we're trying to do is, with a broader ecosystem that initially is, the Cosmos ecosystem, we're trying to bring some really interesting technology standard that they have, which is IBC, so that we can enable trustless bridges across different chains. And we are more like Polkadot native, but NEAR is our first kind of attempt to make this happen outside of Cosmos, which is the native ecosystem, and ours, which is Polkadot. So for us, this is super exciting to introduce a few elements that we believe that needs to be implemented in order to have this up and running. And I'm very happy to be part of this discussion and panel and entire process.
Thanks, Blas. And we're very happy to have you here. And we're happy that you took the time to submit this NEP and discuss it here today. So speaking of that, I think we can jump right into the NEP discussion. So efficient signature verification host functions. And I'd like to turn it back to you, Blas, actually, and maybe have you provide more context, just high level on this NEP, why you believe it is important. And then after that, we will go into the working group members to discuss it. So take it back away.
Yes. So, as I said, the idea is to be able to enable IBC, which is a protocol for communicating between different chains in a trustless way. What does trustless mean is that you essentially do not need to trust on an actor that holds, more power than others. For example, it could be, usually like a multi-sig chain, or, a node that has some, rights that other people don't have. This protocol is kind of agnostic to anything. The only thing that requires is light clients that essentially validate the state of the chain on another chain. And this is something that NEAR actually has. That was probably the main reason that brought us to start with you guys. And when we started sort of thinking, okay, what is the delta for us really implementing this? We thought, okay, there's a lot of things that we need to add, and we really didn't know how to structure everything onto one NEP, multiple NEPs, and this is like kind of a learning process for us as well. And I'm saying this because, as you can see on the title, it says host functions, and we just really narrow it down in the very end to just like a single host function, which is this signature verification. So that's a bit like, if you go to the discussion of everything, you're gonna see a lot of history and things that have been removed, and really like try to make just one change and make it work. And yeah, so the whole point of this is to say, okay, how can we introduce this operation, which is verifying that a signature is valid or not, in a way that is cost efficient? Because these light clients, or most of them, they are they're verifying proof of stake consensus. So essentially, you do have a batch of signatures that you need to from this validator set, and you need to verify. And this is really like an expensive operation that you need to do very often. So so both it has to be cost effective, and also it is ideal is if you can actually manage to process everything inside one transaction. So yeah, what we did is with the help of the core devs, really like kind of figured out how far away we were if we would implement this through WASM, and we noticed that it was like a very big change, and that was not possible for us to do this without really putting this primitive inside the host functions suite. And that's why we're here, and that's why we've been trying to make this work the best we could inside your parameters and framework.
Great. Thank you very much for that intro, Blas. So yeah, we've had the working group members take a look at this NEP and make some comments. And so I'd like to invite Bowen to summarize some of the benefits and concerns that we saw from the comments. So Bowen, please take it away.
Yeah, so there are a number of benefits. So obviously the ED25519 signature verification would enable various bridges, and as Blas mentioned, it would make IBC possible. And also it will allow smart contracts to verify transaction signatures as well, because ED25519 also happens to be the curve that we use for transactions on near as well. And finally, the nice thing about the implementation is that well, ED25519 signatures have already been used extensively in the protocol. Today it is used for both transaction signing and also validators who sign blocks or chunks. So from that point of view, it has already been something that the protocol uses widely. And introducing this as a host function in the runtime wouldn't actually pose much new risks because the implementation has already been used pretty much since the mainnet launch.
Great. So next, we're going to go into the concerns.
Yeah, so one of the concerns raised during the review process is that the NEP does not specify the exact behavior of the ED25519 verification function. It is not a blocking concern. The implementation uses what we already use in near core. So the ED25519 dialog crate. And there are the reason why this is a concern is that there are different variants of the ED25519 signature verification, and it is important as part of the protocol specification to say exactly what this variant is. And I think while this is not blocking for moving forward with the proposal, it would be nice for the author to actually annotate in the proposal itself what is the exact behavior of this ED25519 signature verification function.
Bowen, if I may add, from the moderator point of view, I noted that there was another concern raised just this morning from Alexei Kladev regarding like implementation, defining the return values and like possible error handling for the inputs, and he suggested to also address them before merging the NEP. Just wanted to make sure we are all on the same page.
Okay. Is that is that concern on the implementation or on the proposal itself, on the NEP itself?
So it arises from the implementation, so it was informed by implementation.
Informed by implementation, but okay, maybe I don't fully understand the concern. Is that something missing from the NEP's the proposal itself? That's something that should be.
The suggestion there is to strictly define what should be the return value when you submit invalid lengths of signature or like public key.
I see. Yeah, that's very fair.
So very similar concern, I feel.
Okay. Yeah, I guess I'd like to invite other working group members to share their thoughts and opinion as well at this point. So who would like to go first?
I'd love to ask, this is not a blocking thing for this NEP to be merged, but I see one of the main rationales it's to add this host function so that we can verify like client signatures from other chains. Most importantly, from Polkadot, if I recall correctly. But as Marcin was pointing out, there are other kind of signatures that are also required for this like client to work potentially. So the question is, Blas, do you have any plan for these other signatures? Do you expect this is enough, or what about it?
Yeah, so So this is so when I started researching, I also saw the same file and same link that was shared, and not being a Polkadot expert myself, I thought because Polkadot supports the type of signatures and they using different accounts. I thought, okay, we need to have the 3 type of signatures. But then going a bit deeper into the implementation of the light clients, the Polkadot currently has a light client that's called Grandpa that uses ED25519, and then another one that is Beefy that is not yet rolled, that it uses ECDSA. So I think like the one that was a bit the left behind, that was Snorkel, on the Polkadot side, we don't need it. That doesn't mean that it cannot be needed by somebody else. So that's why I thought in the beginning, the more the merrier. But yeah, given that it is really like a strict process, I think anybody that comes afterwards, they would have kind of a template that they can follow very closely and add any other one.
Got it. So to be clear, it's not completely mandatory to have these other signatures, right?
Not for light clients on Polkadot.
Okay, I see. Yeah, I think adding this signature, it's significantly easier given NEAR already supports CDE on its core. But it'd be maybe this is not the place, but it'd be interesting to discuss as well what kind of if other type of signatures could be added as well to NEAR protocol. If this is something we want to have at the core level, for example, now Ethereum will be depending on BLS signatures, so that could be something interesting as well. A little bit more invasive, probably. You wanted to say something, Marcin?
Right. So what you're saying, Blas, is that if this NEP goes through, you will be able to implement your light client working in a single transaction, right?
Correct.
Okay, interesting. Good. Because one thing I was worried when I was writing that comment was like that, we're going to add this, but then you're going to need all the other types of signatures. So you still need to have like a very complex, multi-transaction code. So adding this would not help. But if you're saying that this can be done in one thing, then yeah.
Yes, that's what we have budgeted and should be enough. Of course, just one more thing, it depends also on the validator size, and this is also something that will grow. So as it grows, there will be more constraints, but I guess we'll figure this out in the future.
Okay, are there any other comments from working group members, concerns, or just sort of opinion on how you're leaning? Or are we ready to move forward, I guess, to the decision? I take silence as we're ready to move forward. Okay, cool. So the next part is in the process is where we get to the actual vote. And I'd like to invite Bowen to kind of, represent sort of the working group's decision based on the comments we just heard and that we saw on the thread.
Yeah, so the working group members have already voiced their opinion on GitHub. So I'm just summarizing the decision for the working group as a whole. If people are interested, feel free to go to the NEP itself to look at the detailed comments from each of the working group members. But in general, we think that the benefits of this NEP outweighs the concerns or the disadvantages it brings. And we think it's important to enable ED25519 signature verification at runtime so that various bridges can be enabled. And I would like to point out that this is not only useful for IBC between or like bridges between NEAR and Polkadot, it also enable other type of bridges. And one interesting use case is actually enable bridges between different implementation of the NEAR chains. And I don't know whether anyone from Calimero is here. But this is an interesting use case that enabled the bridge between the public NEAR chain and some of the private NEAR chains as well. So yeah, overall, the working group is in support of this proposal. And here I'm representing the working group to give the proposal an approval. And yeah, or we can move to the next steps.
Okay, great.
So yeah, so as for next steps, as mentioned previously, there are still some lingering concerns from various people. As summarized, there are mainly two concerns. One is that the NEP should specify the exact behavior of the ED2519 signature verification function that is used in nearest runtime. And the second concern is what Vlad just brought up, is that the error handling should be specified exactly so that it is defined on the protocol level how each invalid case is handled. And then after those are addressed, I think the implementation is already there. As there is a link that's shared on this slide. For those who are interested, feel free to take a look. I think the implementation is almost complete, except the one of the concerns that Vlad brought up just now. And once that is approved, I think we can merge the implementation as well as the NEP proposal itself. And finally, when the NEP is actually live or the feature is live on mainnet, we can update the status of the NEP. Yeah, I guess maybe I'll pause here to ask Blaž, do you have any question regarding the next steps?
I would like to reiterate, particularly on the. I understand very well the concern of handling the error cases, but I don't fully understand what it is expected in terms of the concern, the second concern. Like, can you repeat which one is the second one? But I guess it's linked to the particular implementation of the curve itself. But that is where I'm just like a bit in doubt of what it is that you guys need from me.
Yeah, I think it is sufficient to specify which ED25519 implementation is used so that there is no confusion, as I said, because there are different variants. So I think it is likely sufficient to specify in the proposal itself that this ED25519 refers to this specific implementation as defined by the ED25519 DALEC library that is currently used in the implementation of the protocol.
Perfect.
Okay. Are there any other comments about the next steps or decision? Oh, yeah.
Waiting for Evgeny to type the question.
Yeah. And
Wonderful.
Evgeny, I can also enable you to talk if that's easier. Here, I will do that.
I want to elaborate a bit about this implementation concern because it was me who raised it. So just telling to use the same function that is in ED25519 daily create is not really enough because this create it has multiple modes for ED25519 verification, which depends on the specific function being used and also on Rust features which are used for that crate. So these variants have different behaviors, so we need to specify which exact one is going to be used. And now we understand that it's the same that we are using for our verification of signatures and transactions and various validator messages, but I think we need to specify this explicitly.
Okay. Any responses or other comments? Okay. So yeah, we will also post this in the actual NEP itself after, like just so everyone is aware of the discussion and the decision. And I guess I'd like to move it to Q&A now. So if anyone has any questions, from the attendees on this NEP, the decision, this process, now would be the time to surface those. So we'll give a minute for people to gather their thoughts. Okay, there's a comment from Ilya. All good. Thanks for being transparent. Definitely nice to be explicit about security parameters and implementation details for host functions. All right. I don't see any. Did we get any other questions during the call? I don't think we did. Okay. In that case, I just wanted to reiterate that we're going to be posting this meeting recording and upcoming meetings on near.org/developer-governance. And yeah, I'd like to just say a huge thank you to Blas, the author, for submitting this and for coming here today to talk about this NEP, as well as for the working group members, the panelists, and the community, everyone who's really involved. We all want to make the protocol better, and this is one step closer to doing that. So very excited about that. And yeah, I think with that we can end a little bit early and give everybody 30 minutes back if y'all want that. So yeah, thank you again, everybody. Have a good rest of your day and evening, and more to come soon.